Welcome everyone to the first episode of BYOD, Bring Your Own Data from Einblick. My name is Benedetto Buratti, and I'm one of the co-founder and chief AI officer at Einblick. So what is BYOD? You can think of BYOD as data-driven fireside chats with leading experts from the most diverse backgrounds, and they can come from industries, from automotive to telco, from academia to the government. So during BYOD episodes, we are going to explore together with our guests some data sets of their interest. Hence the name series, Bring Your Own Data. For each episode, we'll be streamed live on our YouTube channel and with our guests connected remotely. The goal of those sessions is to offer to our audience a new way and anecdotes on how to have conversation around data with their organization. In particular, we hope to show how to citizen data scientists how they can leverage tools like Einblick to boost their data science skills and spread a data-driven culture in their teams and organization. But let's now talk about our guests today. Brian Sandberg. Brian founded Conarch in 2009, where he leads the research and development efforts for the DoD and intelligence agency, including the Naval Research Laboratory, Office of Naval Research, Department of Homeland Security, National Reconnaissance Office, and DARPA. Brian has been a scientific, engineering, and technical advisor for DARPA since 2013. He has held executive leadership roles at Veridian Technology and CET Corporation. Brian has a bachelor's degree in mathematics from Kent State University and graduate degree in applied science from Harvard University and geoscience from George Mason University. Brian served 9 years within the United States Air Force. So as a personal note, I'm particularly happy to have Brian with me today. We had the pleasure to collaborate with him for several years since Einblick was still a research project at Brown University and MIT. And so again, I'm really happy to have Brian today. And how are you doing, Brian?
Oh, doing well. Thanks for the introduction.
So Brian, which data set did you bring today to analyze?
Okay, so today I brought data collected by the Armed Conflict and Location and Event Data Project called ACLED. And so ACLED collects data on reported conflict events from a variety of public sources, and they manually code them across a wide range of features. And presented here are some of those key features to include event IDs, the event date, event types such as battles or remote violence or protests or riots, actors, the actors involved in the event, both the aggressor, actor 1, and the victim, actor 2. And then you have a bunch of location information. You'll see that they identify the region. This data set is Central Asia. It also includes the country. And you'll see admin regions, which the administration 1 and admin 2 and admin 3 typically just drill down in closer scale. So admin 1 is like a province or a county.
So admin 2 is like the city and so on?
Yeah, like a town within that county or province. Then you have latitude and longitude information. And they provide like a description, a text description of the event under notes, and the number of fatalities that are estimated per event. And so I think the only point I want to make about the data, because I'm interested in looking at fatalities, these estimates that ACLED makes are also vulnerable to both bias and inaccurate reporting by the countries. So it's good to take this into account when you were doing the analysis, but they're also a good indicator for regional violent conflict. So looking at the looking at violent conflict versus peaceful protest without casualties or fatalities. So this is still an important feature, and I'd like to get into that a little bit more if we can look at the use case that I'd like to explore with you. I looked at this data. It covers, like I said, Central Asia, which occurs over 2017 to 2021. But today I was hoping we can just focus on Afghanistan. So if we could be able to filter down to that country. And I wanted to look at some estimates on fatalities if we could, because ACLED did not estimate fatalities. in the first quarter of 2021. And this was due to shifts in reporting and lack of accurate reporting. So we don't have any estimates for 2021. So I thought we can build a predictive model that will help estimate these fatalities over that period of time when these fatalities were not reported by ACLED. And then I would like to see if we can compare that violence and fatalities in the various Afghan provinces, both in the historical data, 2017 to 2020, and then compare that with the violence and fatalities in that same provinces in our predicted period, which is 2021. So that's kind of what I'd hope to be able to get out of this exchange.
Mm-hmm. So essentially, the end result of the analysis that you're looking for is to have on one side historical data, and then with some visuals and descriptive analytics, and then build pretty much the same thing, but according to the prediction of the model. Is that resonates with you? This type of analysis. All right.
Yeah.
All right. So the outline of how we're going to tackle this task, Brian. I took a quick look to the data set before we started here. Is to break down in different steps, right? So the first steps are quite straightforward. It's mostly related to data ingestion of the data and start building some visual to understand how the data looks like. I know that you already went through the columns of this data set, but maybe we can get more info there. And then just start drilling down to Afghanistan, start to understand and map the violence there. And then again, given that your goal is to estimate fatalities, just to work on model building and refinement to be able to build a dashboard. Does it sound good for you?
Yeah, sounds reasonable. All
right. All right. So what I'm going to do now is to jump in a workspace here. And what I have here is data set that already brought into the workspace. So I can see that Brian is already connected to the workspace. And what we have is the raw ACLED data set. So for example, what we have is the table with all the attributes that were first described by Brian. So I'm going to zoom in a little bit just to have some clarity for the people that are watching this. So you can see there is the event, dates, the year, the time precision. But again, this data set contains all the information for the all Caucasus region, right? So what I'm going to do now is to just show this data set to Brian, and maybe we can talk about what to do next. So Brian, what I did is maybe we can also go live here. So let me start the live so that we can directly interact in the workspace.
Okay,
so here on the left
now, does it look to you on live?
Yeah, perfect. Yes.
Okay.
I can see you. So I have the profiler. It's the reason why I run this operator is just to get a quick overview about the data. So everything looks as expected, the fatalities and the distributions. What I was interested in on my side, I just wanted to take a look to the temporal component. So as you said, in this data set, we have those violent events from 2017 to 2021. So it seems that also, there's this kind of trend up and down across the seasons, and then it seems that even from 2020 there's a little bit more downgoing trend there, probably due to COVID. But what was striking for me as you were talking about this during the presentation is that if you actually plot the number of events across all those countries, Afghanistan really stands out. I mean, maybe probably it was expected. But I just plot this simple visual where I have, on the x-axis the country, and then on the y-axis the number of events across the 2 years. And Afghanistan is clearly the top one. So where would you like to bring the analysis from this point?
All right. So can you filter that on that country? So if we just take the Afghan data, so we're only working with one country?
All right. So what I'm going to do here,
51,000 events in Afghanistan.
Yeah. All right. So let's filter down this data set first. So I'm going to take this table here, and then what I'm going to do is to use this visual that we produce to filter down this table itself. I'm going to remove the link. So now, Brian, you can see the number event went down to a little bit less than 50,000. Actually, it's 51,000 events, as you know, was reported by the chart. And so this data set is related to Afghanistan. So we don't have other countries in the region.
Well, ultimately, I'm hoping to be able to compare these provinces. So if we can start with the historical data or looking across the entire data set of Afghan, to make a couple plots. Have a plot that compares events against provinces, which would be admin 1 on the x-axis, and then do the same thing with provinces against fatality, so we can see the trends across both of those types.
All right, so I found the admin 1 entry. Let me just plot this real quick. So the first plot that you said, just to be sure, you want to just have a ranking, like a visual that shows which are the provinces that are most active?
Yeah, by event. So first by event.
All right, so in this case, the data set here, we have the element, it's the top one in terms of just events, right? We're not counting anything else. So
correct.
With 5,000 events. And then which was the other one?
Similar plot, but just fatalities on the y-axis.
Okay, all right. So what I can do here is actually just duplicate this plot. And then I can select on the y-axis, fatalities, then use sum. So in this way, what I'm showing is the total count of total sum of fatalities for each of the provinces. And actually, the ranking is a little bit different. So here we have that instead of being Helmand is Nangar. Is this? Yeah, and the second one is Ghazni. Yeah.
Nice. Okay, that's good. So I want to keep these for later because I want to compare these kind of stats with what we do in prediction of the 2021 period. So I think we could. I don't know if we could just start preparing a model of the training, using the whole data set here, except for 2021.
Yeah, so in terms of the model that you were talking about before, so I understood that for the last 3 months of 2001, there was like some missing data or something like that. Can you just iterate a little bit on that? Maybe we can build some visual also for that.
Yeah, when I got this data set, 2021 had null values for the fatalities.
Got it. Okay. So
yeah.
does it mean that it completes it like we know about the event occurring, but we don't have official estimates essentially?
Exactly. So the features are rich there. I mean, they're complete except for the fatalities. And I think that's the reason. I'm not absolutely sure, but I think that has to do with the reporting biases and inaccurate reporting by the countries during that previous period. So I think they just did not manually code those. So I'd like to replace manual coding, what they would manually code with what we could consider as our best predicted estimates for those values.
Got it. So I'm just curious about this. I want to see if this is reflected in the data. So let me plot the fatalities against time. Let's do so. Oh, okay, I can see it. So essentially, is this section here of this plot, everything is 0, so it looks like there's no fatalities, but actually it's just missing data, right?
Yeah, that's exactly what we were looking at.
Got it. Okay, so I see what's the issue here. So what we can do again is to start building a model on this type of events, and then start to use this model to predict for those entries. Does it sound like a plan for you?
Yeah, that'd be great.
All right. So the first thing that I want to do together with you is because this data is so rich, contains so much information that I need a little bit of guidance from you, because also a lot of attributes. I saw there was actor 1, actor 2. I'm not really in that. They're encoded with some numbers, right? So I'm not really sure what those type of number means. So In that term, your supervision would be really helpful while we build the model. So I'm gonna drag out the AutoML, if you can follow me here on the workspace. And what I'm gonna do is just to select the entries for which we don't have those values, so for which is null. So the first operation is just data manipulation, pretty straightforward. So I'm gonna filter here. I'm gonna select fatalities, and I can select is not null, so that we got rid of those entries from this div here. And then now that we have this data set, maybe what I want to do is just to build a model based on this data. So we can give that as a train, and then maybe I can just start building a model and try to predict fatalities, and then we can iterate on the features. All right. So I'm gonna just add all of them, and then we can discuss about this. One question that I have though is in terms of evaluating this model, right? So there are different kind of metrics that we can use. Some are more accurate in terms of mapping the error, but are a little bit harder in terms of interpretation. Like, do we have specific requirements here? Like, what your target audience would prefer? Like, do we need to be do we need to trade off essentially an error measure that is able to capture what's going on the most accurate, or we also want some degree of interpretability for the error?
Yeah, I think using a metric that could easily explain the relationship between the model and the target variable of fatalities would be a reasonable choice in metric.
All right. So because what I was thinking is to use mean absolute error, so that it's pretty straightforward to evaluate and what's going on and what it means in terms of the prediction. So let me just run the AutoML here. So that the AutoML on I just put a really quick iteration here with just a 30-second evaluation. So the naive score is right there on the top. And so the lower the values that we are getting, the better, right? So we have on the x-axis the runtime of the AutoML, so we can see that we have this dynamic that of diminishing return. So the more time the AutoML has to find models, the better the performance that we got. So seems like the best model, if we just use all the data available in 30 seconds, is not that bad. We can maybe just check out the performance, and maybe we can. What I like to do is just iterate real quick on this model. So what this is saying is that on average, the absolute error on the prediction is of 2.2, right? We can definitely do better, but at this point, to improve this model, I think I really need your assistance in terms of knowing what those features mean.
That's reasonable. That's reasonable performance out of the box. What kind of pipeline was constructed here?
So in terms of pipeline, we have some pre-processing steps with the label encoding. So this is essentially manipulating the data set in a way that categorical attributes can be processed. Then timestamp converters, and then given there are some other missing values, for example, we have some imputation strategy, scaling, and then the regressor itself, it's X gradient boosts, and so with the hyperparameters.
So the label encoder took care of the actors and event types, and there's other categorical variables.
Yeah, exactly.
Okay. I don't see any.
It does everything on its own. Yeah.
I'm sorry.
Yeah. Essentially, the AutoML engine is not just a model selection tool, right? So it actually goes through the whole pipeline, and you can actually, maybe if you're interested at the end, we can also export this in a Python snippet.
I don't see anything in the pipeline that that took advantage of the text field and converted or extracted the text field. Has that been taken advantage of by the AutoML, or is that something we can like?
So we can also do it. Yeah, we can do it on our own. Actually, we can do some text processing if it's available. Like, do you know anything in this data set where this would make sense?
Yeah, so there is a notes field that describes the event that if we can extract that into a numerical variable, that would allow for us to get maybe some more insight into the
All right.
model performance.
All right. So let me try to go over this. And first of all, I want to check this description column here. All right. Yes. Notes. I found it. All right. Uh, so you're saying that we want to use these nodes to actually boost the model performance. All right. So what I'm going to do here is use the word extractor operator and give this to this operator the input data set.
I think
All right.
both. I think this can help in two ways. I think it may help in performance. It could
Oh,
also
yeah.
probably help in when we explain our model, have some indicators of explainability as well of the global model.
Got it. So in terms of explainability, probably what you're looking for is not to overload the task with too many words. So maybe probably the top 10 words make sense for this task so that, just the most important ones get used, and then we can use them to understand what's going on in the model. This sounds
Yeah, I
like
think
a
the
plan
top
for
10
you.
is a reasonable starting point.
All right. So maybe let's run this in this way. So what this will do is produce a model, an executor that will be able to go over the field that we used before and the notes one that I selected as a target. And then what we're going to see is the original data set that we had plus this extra 10 columns that represents the top words in those notes. So let me just show it to you. If you scroll all the way on the right, what you can see is that we have Afghan, district, fatalities, forces, killed. So those are the top 10 words. The Taliban's, province. All right, so it seems
Awesome.
to
Yeah,
be
that's exactly what I was looking for.
And so at this point, what I'm going to do is exactly what we said before. I'm going to quickly iterate with the outer mel and build a new model so that we can evaluate how this looks like. As usual, I need to filter down and remove the entries where fatalities are. I just want the ones where fatalities not null. So I have my 48,000 entries out of mail, target variable fatalities. Actually, fatalities also was in the node too. So I think that we're gonna have a nice boost there in terms of getting information from the description.
Hey,
And
Ben,
in terms of, yeah.
hey, I don't know if you're about ready to run. If you're not going to run this right away, can we remove some of these noisy features? I see ISO, which is a constant variable, and a few other event IDs really are not useful to the model. Can we also at the
Oh,
same
yeah.
time just remove those?
Yeah. So let me select all of them and then I can go through the list. So ISO is said the IDs, event date looks fine, at time precision. Probably we should also remove country, right? Like it's always Afghanistan, probably.
Yeah, it's another
Category one.
constant variable. Yep, yep.
Yeah. All right. So let's give it a try. So at metric, we're still using mean absolute error, and then we can also increase the runtime just to we don't need to wait for the whole thing to run, but it would be nice to see maybe if we have more time for the model while we keep going with our analysis. So what I can see is already that performance are much better. Yeah, the model is much better now. I'm really interested in seeing how this looks like and which are the variables that drive in the performance. So we have an improvement, quite a bit of improvement, like a 10% improvement on the error. So maybe I just drag a pipeline. If the outer melt is able to find something better, we can always come back here. But let's keep going with our analysis. So pretty good mean absolute error, Brian.
Yeah.
Um, in terms of yeah, what we want to do with this model.
Well, I think what we were hoping to get out of this feature extraction on the text field is see if we get some good indicators in explaining the model. So can you look at some way of explaining this through feature importance?
Got it. Yes. So let me drag out the explainer here. So it seems like that source and source kill are the top two, but also the features that we extract are pretty important. Kill the militants in terms of the description of the event itself and the actor. So I'm not really sure what actor two means. Like, do you have any insight about actor two here?
Yeah, so actor two is the targeted or the victim that would be the counterpart of actor one, which is the aggressor. Now, also we have here enter one, which is a numerically encoded value for actor one. So actor one could be described many different ways, and they categorize these into one of 8 different numerical categories. So this represents the enter one represents the category of the attacker. Actor two represents the victim. And it looks like we have a couple clear text fields. And the source of the reporting seems to be like a very important attribute here in terms of the relationship between some of these other fields. So this is interesting insight here. What this represents, though, I think, is a global view on the features importance. And I happen to have an event that I'm aware of, and I want to see how well your predictive model establish some of my trust in this model. The event happened. I have an identifier here of 1149, and if you find that event in your predictions and let me know how well or what you predicted for that event.
Yeah, sure. So this is one of the events where we don't have estimates, just to understand the task.
This is so. This would be this is where we don't have estimates for the fatalities, and I'm aware of an armed clash that occurred on January 24th of 2021, and there's fatalities there. So I'm wanting to see whether the model correlates with my intuition.
All right. So what we can do here is we have our executor from before. We extracted all the interesting textual columns here, but what we want to do now is to, instead of, as we did before, to keep just the entries where the number of fatality is not null. Now we actually want the one where is null. So it's just the last 3 months. That's why we have like 2,500 entries. The nice thing is that, Brian, given that you want to check out a specific event, what we can do is to use the executor from the model that we just built and give it as an input here. So the executor should give us a really good idea of what's going on during those 3 months. So what I can do is to sort this in a descending order. So all right, so there are quite a bit of events that they are predicted to and estimated to have quite a bit of fatalities. Can you tell me again which one was the one that you were looking for in terms of fatalities?
The one I pulled out was event ID AFG.
One second,
AFG 5 1149.
1149. All right, yeah, I found it. Yeah, all right. So the model is saying that for this specific event, it's predicting 15.4 victims, so roughly like between 15 and 16. And so the event was on the 24th of January, right? And let me just check so it's the military forces of Afghanistan. So actor one again, is the attackers or the defenders?
Actor one is the attacker.
All right, so attacker is the military forces. Actor two is the Taliban's. Yeah.
So it's intercode probably 1, which is the state forces. So state forces of Afghanistan or the military forces of Afghanistan.
Yeah.
Targeting Taliban, which is probably intercode number 2. Is that right?
Yeah.
Okay, we got the right event. That's a good prediction. I mean, there was definitely fatalities. on this event. The model seems to be, matching my expectations, so that's good.
Would you be interested, like what we can do also is to get more fine granular explanation, right? Why the model made that prediction, if you want to drill down in the specific entry here.
Yeah, sure, that would be good. If you can go down further, that would be excellent.
Right, so what we're going to do real quick, actually I can use the explainer from before, right? Let me see here. I'll give it as an input. Samples. This is our prediction. So let me remove the normalization. So it seems that in this case, yeah, it's just that the source is the Ministry itself of Defense Afghanistan that tweeted about this, the actor too, and the timestamp, the location that happened, and in the notes also the word Taliban occurred multiple times. So those seems to be the driving factor that are pushing on the right the predictions, right? So on average, a violent event was predicted to have around 3 victims. In this case, we have almost more than 15 because of those factors. It's really pushing the prediction on the right up.
Awesome. No, that's perfect. I guess, what we didn't do is maybe have a graphical view. I'd like to be able to package this up into like a dashboard or a presentation. We didn't look at the map views, which would be helpful for a presentation, kind of like the before, like what the historical data showed in terms of provinces and conflict, and just have it in a graphical form versus the plot.
All right. So what we can do is also, I would just quickly go back to what we did before so that we have keep track of everything. So what you want to do first is to visually see in terms of violent event in the past, right? So I want to plot an Afghanistan map here using this operator so that we get a view. And again, like, do you want to build a dashboard or do you want to keep those just in the workspace?
Well, I think they just want to get the maps generated and then use those in the dashboard.
All right. So this one, all right. So this is the visual of a plot that we also generated before. So Afghanistan Nangarhar is the top one in terms of historical data, and then we have this other region, Ghazni and Kandahar. So let's add this to the dashboard first, and then. Is there anything else that you want to add that we already produced, given that we went a little bit back here?
Well, you see the map we just produced. I'd like to have that same map for the predicted regions of the provinces, because I haven't seen the plot yet for what is the most violent predicted province in Afghanistan in the unreported period.
All right. So let me do that real quick. So in this case, we have our executor that it gave us interesting predictions. And what I'm going to do is to use the Afghanistan map. But now I'm going to run this on this new attribute. So admin1 value predicted fatalities so that we can see. So it seems now, based on the model prediction, that the other regions are still quite violent. Yeah, Nangarhar is still there. Ghazni a little bit less, but Kandahar dramatically different, right? Like it seems that it's really the dominant one.
A fairly different picture of where we expect violence in that region. Okay, yeah, that's exactly what I wanted. I want to be able to compare those two maps in the visual, so I'd add this to the dashboard as well.
All right, so I'll add this to the dashboard, and maybe we can have what I like to do in those cases is, just have some connected plots in a way that we can map, and the dashboard can become a little bit interactive. So I can take this entry here, and given that you seems to be really interested in the province, what I want to do is to just create this type of mini dashboards with those visuals for you. So maybe we can do like a admin one, and then is there any other attribute other than the province that you're interested in, you would like to relate? Can be, I don't know, like the attackers, can be the defenders, can be the violent event type. I'm not sure if there are other attributes in the data set that you would like to connect.
Yeah, that'd be nice to be able to look at the actor 1 and actor 2 for each of the, or enter 1 and enter 2. Either one of those would be a good additional plot for this.
All right, so let me quickly do that. So actor 1 and actor 2. So, all right, so this is actor 1, actor 2. All right, and so you want to be able to see for every province who is the most active. And this in terms of fatalities, right? Like you want to plot this in terms of which actor was the active actor in terms of producing fatalities for that event.
Exactly. Yeah, that's perfect.
All right, so I'm gonna sort this one. Do the same thing, fatalities also for the passive actor, so predicted fatalities, and some. And let's also sort this plot here. All right, so now we have those two plots, and I'm gonna connect those visuals to this one. So filter as we did before. So for example, if we just select Kandahar, seems that the most active actor is the military forces, and the most passive actor are the Taliban's. So you can play with the dashboard, Brian, with the visuals that I just produced. Yeah.
So Hellman, I'm just drilling down on Hellman.
Yeah, we can also remove Kandahar. Yeah.
Yep. So thank you.
Yeah.
So again, this is very helpful because I can quickly see now Taliban is the more aggressor in Hellman versus, being more of the victim in.
Yeah. So the situation seems to be different.
That's nice. That's awesome. If this can all be put in a dashboard, this would be helpful.
All right. So let me add also this to the dashboard. So all of those would be in the dashboard here. And maybe just given that we want to do this mapping, I can put the model that we just built, this pipeline. Let me add it here. And then finally, this last two plots that we really did at the beginning, just so that you have the comparison.
The last, going from that model, the last model that we generated, can you also include the code for that so I can bring that into a notebook later?
Yeah, sure. So what I can do is go to the pipeline and I can export this. So let me export the code and I will send you this. I'm going to send you this email later on. All right.
Yeah. Well, thank you, Ben. That was awesome.
Thank you very much.
Can we look at the dashboard from the elements that you selected? And
yeah, so let me select the dashboard here, and so here this kind of the outline a little bit that I have here. So before and after, in terms of the which provinces are more active in terms of fatalities, the different regions. With the different provinces with actor 1 and actor 2. So again, this is interactive. So if you have someone that wants to play with this, they can play and see which are the most active actors. And this is the admin 1, admin. So admin 1 for the number of events and fatalities and the model itself. So you can also show which type of pipeline we used here.
Awesome. Well, thank you. That was very smooth. Appreciate it.
Thank you very much, Brian, for bringing this data set. I hope that was interesting to see this type of use case. What I want to do now is to go back 1 second to together with you, Brian, and go over the outline of what we did today before. So we went really from data ingestion, so bring the data inside of the platform, build some descriptive analytics, manipulate the data, and narrowing down to Afghanistan, model building. First iteration that we did, it was pretty good out of the box. But then talking with Brian, we refined the model, we extracted some feature from the text, we removed some redundant or noisy features, and finally we used this model and all the artifacts that we built to create a dashboard. All right, so maybe what we can do is actually maybe there are some questions from the audience, and I don't know that Mark is reading and monitoring the Q&A. Maybe Mark, do you have any questions for me or Brian?
Hey Benedetto. Hey Brian. One question that came. Can you guys hear me?
Yep.
Yes.
Perfect. One question that came in right now, it says, what can you plan to do with the insight from your model? I'm not too sure which model the person was referring to. It was maybe like, was it about 10 minutes ago or so they asked it? But speaking either to the specific model at the time or more broadly, what kind of action can you take, or what can you do with the insight from the models that you guys generated today?
Well, you know, I think the first thing was, well, what I was interested in at least, is that the reporting process for fatalities was lacking in this data set. And I wanted a more complete data set so that I can do some more analyses downstream. So having this kind of being able to populate and complete some of this data set was kind of like a pre-processing step for me, to better understand where violence has shifted. And so I think the analysis I'd like to do downstream, and the benefit of having like a live kind of a dashboard, is just to get better insights on how these patterns have shifted. Unfortunately, the ACLED data set is only from 2017 to 2021, with some limitations with reporting. It would be nice to be able to see these trends that occurred throughout the period and maybe build a longer forecast model to assess and be able to analyze future events.
Perfect. Thanks.
Are there any other questions?
That was the only one that came in.
All right, perfect. So thank you very much, Brian. So this is the end of this first episode. Thank you very much, and thanks for joining us. It was really cool to have you today, and thanks for our audience and viewers to tuning in. So what I want to say, just as a conclusion, is that if you're interested in trying out Einblick or exploring workspaces, you can go on our website, Einblick.ai, and you can start your own instance of Einblick and just play around with some template data set, or just upload your data. And if you want more information, you can actually go and write to contact@einblick.ai. So that's it today, and thank you very much. And thank you again, Brian.
Thank you.
Bye-bye. Bye, Brian.